Welcome back. So get this, a project that sounds like it's straight out of science fiction. We're talking about a plan to build a river, an artificial river, twice as long as the Nile, completely underground, right through the Saudi Arabian desert. You know, when you think of Saudi Arabia, what comes to mind? Probably oil, right? Incredible wealth, and just sand. Endless desert. But here's the crazy thing, the central paradox. It's the biggest country on the planet that has no, and I mean zero, permanent natural rivers. And yet, despite having no natural rivers, they're building one, a massive, man-made underground river network. We're not talking about a small pipe here. This thing is so vast that it's going to be twice the length of the Nile. Yeah, the longest river in the world. Okay, so this just begs two huge questions, right? First, how is something like this even possible from an engineering standpoint? And second, in a country that gets almost no rain, where's all this water supposed to come from? Well, to figure that out, we've got to go back and understand the problem they were trying to solve in the first place. So let's break it down. For Saudi Arabia, water isn't just some resource you turn on the tap for. It is the challenge, the single biggest threat to its existence and its future. I saw this quote that just nails it perfectly. It's like having a palace of gold, but you've only got 2 sips of water to drink. Think about that. All the oil money in the world means nothing if you can't get a drink. And that's the core dilemma they've been wrestling with for decades. So you might be wondering, how did they get by for so long? Well, for decades, they had a secret weapon, a hidden source of ancient water. But what started as a solution, well, it turned into a massive national crisis. Turns out they were tapping into something called fossil water. This is basically ancient water that's been trapped deep underground for millions of years. So back in the 70s, they had this really ambitious plan. Let's use this fossil water to grow wheat in the middle of the desert. And for a while, it worked. But fast forward to 2003, and farming was guzzling 85% of all their water. By 2016, NASA satellites were sending back these scary images confirming what everyone feared. Those ancient aquifers were just vanishing fast. And look at this. The numbers are just staggering. That massive slice of the pie, 85%, was all being sucked out of the ground just to grow crops. It was this grand dream of being self-sufficient, but the price tag was a resource they couldn't get back. It's like having a battery you can never, ever recharge. Once you use it, it's done. And that's what fossil water is. It's a one-time deal. Once it's gone for millions of years. So yeah, this whole approach was a dead end. The kingdom had to do something different, and they had to do it fast. And that something different is this project. A plan so unbelievably ambitious, it sounds like we're making it up. An underground, man-made version of the Nile. Let's just talk numbers for a second, because they are wild. The whole network of pipes, it's going to stretch for 12,000 kilometers. That's just mind-boggling. And through these pipes, it's designed to move 9.4 million cubic meters of fresh water. Not in a year, not in a month, every single day. But, moving that much water takes a ridiculous amount of energy. In fact, just the pumping stations for this river are expected to use up 9% of the entire country's electricity. Just for this one project. And this is where the engineering just gets insane. We're talking about pipes that are 11 meters wide, and they're designed to do something natural rivers just don't do. They're going to pump all that water uphill, fighting against gravity to get it to cities that are way up on high ground. Okay, so we've kind of covered the how, but that still leaves the big question of where. Where does all this water come from? The answer is the ocean. And it all comes down to a single technology that really makes the impossible possible. Desalination. So there are basically 2 main ways they do this. The first is called multi-stage distillation. You can think of this as the brute force method. You're basically just boiling huge amounts of seawater in stages and collecting the steam, which is fresh water. Then there's reverse osmosis, which is a bit more elegant. It uses super high pressure to push seawater through this incredibly fine filter, a membrane so tiny that the big salt molecules just can't get through. On the surface, it sounds like the perfect solution, right? A miracle, even. Unlimited fresh water straight from the sea. But, like with a lot of these huge technological leaps, there's a big and often hidden environmental price tag. I mean, think about it. When you pull this salt out of trillions of gallons of seawater, where does all that salt go? Well, It turns out the whole process creates an absolutely staggering 329,000 tons of waste. And that's not per year, that's every single day. And we're not just talking about table salt here. This stuff is a super concentrated, toxic sludge called brine. And guess where it goes? Yep, pumped right back into the ocean. Okay, to give you a sense of scale, that's like taking 1,600 blue whales and dumping their combined weight into the sea every day. This super salty, warm brine, it just sinks and suffocates all the marine life, creating these huge underwater dead zones where basically nothing can live. So you see the pattern here, right? They solve one massive problem, no fresh water, and in the process they create a whole new one. So what's next? What does the future look like for a kingdom literally built on manufactured water? Well, they're already on it, looking for solutions. One idea is to use these things called deep sea diffusers to spread the brine out so it's not so concentrated, kind of diluting the damage. But an even cooler idea is something called brine mining. Basically, looking at this toxic waste and saying, hey, wait a minute, this is a resource. And then pulling out valuable stuff like magnesium and potassium. And all of this leaves us with one big final question. This artificial river, it's an absolute monument to what humans can engineer. It's incredible. But does technology like this actually solve the problem of scarcity? Or does it just transform the problem? Does it just kick a brand new, maybe even more complicated can down the road for the next generation to deal with?